Hello, everybody, and welcome to the session on how we at Proximus utilize Dapr and how we use Dapr to actually improve our time to market. So my name is Xavier Geerinck. I'm the technical lead at Proximus. I'm an AI and IoT specialist and as well active as a Microsoft MVP in the community. So first of all, to get started, so who is Proximus? Because Proximus is well known in Benelux market, but it's not that well known outside there. But so Proximus is actually the biggest telecom player in Belgium. As Proximus being, we offer normal telecom services such as connectivity providing at the customers as well as of the residential homes as well as of our businesses. For the residential homes, it's typically installing a box and ensuring that they can get connected. For the enterprise market, it's more okay providing SIM cards for machine-to-machine communication, narrowband communication for narrowband IoT, as well as LoRa and other connectivity protocols. But we're not just a telecom player. So besides being a telecom player, we as well provide digital services to our B2B and B2C customers. In the B2B market, it's the team I am in. We call that the enterprise business unit, where we really focus on the enterprise customers in Belgium and assist them in their digital projects. And for our B2C customers, we provide innovations in certain sectors. So, for example, one of the sectors is energy, which we do together with Augie. Then we as well have banking, where we created a dedicated bank portfolio for our customers, and then the health sector, where we have an application called Doctor to provide them some services as well there. So on the enterprise market, so in this presentation, I will mainly as well focus on the enterprise market. So for our enterprise market, we have certain accelerators, which are affiliates of ours that we utilize to get our partners up to our customers up to speed. So one of the most famous ones on this slide is Coded. So Coded provides consultancy services and was as well named as Partner of the Year for Microsoft. To then give maybe a brief oversight of, okay, so as a telecom player, it's something in Belgium there are just a couple of them, and Proximus is by far the biggest player in the market regarding coverage. So we have 3,500 cell towers, and of those cell towers, so each cell tower is a certain region, but we divide that in cells. Mostly we have 3 cells per cell towers, which makes us have a coverage of 11,000 cells, creating up to 2 billion records per day that we have to ingest. Because of these cell towers, we can offer certain data to our customers, such as location analytics, what's the most likely living space situation, where are our customers coming from, so that, for example, if you're a city, you can ask us, okay, what's the tourism look like? We can say these are the day tourists, these are longer tourists, so for weeks or longer. These are just the residents of Belgium. We can really drill that down and give cities an overview of who is visiting their city and what is happening around there. Besides just, of course, providing normal coverage for 4G or 5G communication. Now we're well known for being in Benelux the biggest telecom player because we have the biggest market share, but it doesn't just stop in Belgium there. So we as well have a worldwide network. So for that we have a company named Bix, which is 100% owned by Proximus, and that provides connectivity worldwide. So we invested in almost all of the main lines that are currently in cables under the sea, so that we can offer connectivity to more than 70 countries and have 120 access points of presence across those countries in around, let's say, 20 submarine cables that are connected. Now, how do we work with customers in our enterprise segment? So that's mostly in an end-to-end fashion. We really believe in owning the entire vertical chain so that we can provide the assistance that our customers require, which range from, okay, just starting the initial consultation of what is the project, what is the scope of the project, towards finding the sensor that is required for that customer, connecting that, installing that, analyzing that in a secure manner, towards finally integrating that and providing insights on that data. So if I have to list that up, so that's really we go from connecting the things so that we can collect the data, that we can offer predictive services to our customers, which is where really the value is at. For my team specifically, so I'm situated in a team which we call the IoT Solutions Team. So the purpose of our team is that, okay, we know IoT, it's everywhere. So the Internet of Things is growing. There are more and more of millions of devices coming online each day. which we have to break up in four specific categories. So first of all, we have the things, which are our sensors. They need to send and receive data. We have the connectivity, which has to transport the data. We have the application that needs to somehow make sense of that data and provide some services on top of that. It really creates the value for us. And then we have the services to actually make sure that the device stays in operation. And when we look at our customers, we often see the same issues popping up. So for us, it starts, okay, we in our portfolio, just to provide a small overview there, we have a lot of different sensor types, and they come from different sensor vendors. So for example, for ANPR, which is the camera that we put on the highway to create a control of, okay, what is the speed that a certain car is driving between 2 points, where we first capture the car at point A, then at point B, then we get the differentiation, and we say, okay, this is a car that is in violation or not. That's an ANPR camera. We integrate that one. We as well have air quality sensors that provide us an overview of, okay, what is the air quality in our neighborhood now on a detailed level, which was really popular during Corona times. Um, then we have 3D cameras, normal cameras, GDPR safe sensors such as millimeter waves for crowd detection. And we as well have some in-house built solutions such as a tug car counter, where we analyze a certain sound to say, okay, this is now a tug car, and in Belgium they make too much noise. So we want to start giving them a fine so that the neighborhoods doesn't only get safer, but as well gets more peaceful, which is what they're eventually looking for. Beside of just having these different sensors, we all know, okay, there's one thing of purchasing it, but then that's a small bulk of the work. But then you have to start integrating that. And when you look down on a technical level, you use different protocols for that. So typically across these sensors, we see HTTP being utilized. We see MQTT being utilized because AMQP is typically too big for payloads on these sensor devices. We see WebSockets, and then we as well see some custom ones. So the custom ones are by far the most difficult ones because they create a very like a mix of these different protocols, for example, that I mentioned earlier. Like we have a sensor that uses MQTT to start up a WebSocket, and then MQTT again to control the WebSocket while the data flows over the WebSocket, to just give you a small idea there. Yeah, we have another vendor that creates a known proprietary protocol that we have to reverse because the customer wants to ingest data, and that protocol is based on UDP with its own headers, and then we have to start working with that and start integrating that. And if that's not even difficult enough, we need to actually connect that data. So the sensor is creating data, it has its own protocols to transport it over, but how are we going to connect that? For that, we are uniquely positioned in Belgium because, of course, as a telecom provider, the main USP that we have is providing these different connectivities with the coverage areas that we have. So we can do 5G, 4G, the typical ones. We can do Wi-Fi, Ethernet, or even narrowband IoT, and even all the others, such as, for example, LoRa. We can definitely use those to connect all the sensors, and we do use those in almost every day. So to summarize that, um, the customer needs that we detect often while working day to day is that, okay, we have at one hand the sensors, which is 80% of the. You need to figure out which sensor to use. You need to have contracts in place for reseller value, and you then need to as well work to make sure that you can get that sensor integrated. Then customers want to be able to connect those sensors, and then as a telecom provider, we offer them certain services so that they can start connecting their sensors. And then the customers, of course, they don't put the investment of getting the sensor, selecting the sensor, and connecting that just for the sake being. They really want to get insights from that. Typical in Belgium with the ecosystem and the position it is at now, we see that they just want dashboarding. So it's plain intelligence. And then finally, what we really want to help the market in Belgium to move towards is to actually as well perform actions. So that's really the ultimate goal. We want our customers, based on their data, to provide actions as soon as something happens. To give you an idea, one of the use cases we were working on is that there is a road and it's a little bit uphill. And during a certain season in the year, some vehicles are driving too slowly. So we detect the speed of those vehicles, we ingest that, and then we state, okay, if the speed is below a certain threshold, we display on an LED screen, be cautious, there is a slow vehicle ahead, so make sure that you don't collide with it to reduce the risk of collision and to, of course, make the flow on the highways smoother. So we created as Proximus a platform which we named the IoT platform that helps to deliver this journey to our customers, which is an end-to-end platform for customer sensor management. So we really go from ingesting these different kind of sensors towards finally providing value. So that customers can log in on a portal through a normal email password combination or with a Microsoft AD integration, so SSO integration, so that they can get access to their sensor data. So for example, here you see an AIPR sensor that we connected in real life, where data is coming through. I think the delay is almost 2 seconds here. It can go even faster depending on the speed of ingestion of the camera itself or the sensor itself. And from within those 2 seconds, we're able to go from camera capturing the event, sending the event to our systems, pre-processing that, modeling that in a twin. So we create a digital twin of everything, but I will go more in detail a little bit later. Towards visualizing that on the dashboard on the back office, where customers can see the events coming in. And this platform is just for managing their sensors so that they really can visually see that something is coming in and that everything is working as expected. And this platform is being developed continuously in an agile way so that we can keep on providing more functionality to our customers. And it's as well not the main entry point. So the main entry point for our customers is always custom, but we wanted to create a platform where customers really can do anything that they want, where we can provide the custom part, and then the platform will deliver generic parts such as the sensory management. Now, to go through some of the use cases that we as a team cover, which really range in variety. So one of them is truck height detection. So there are certain bridges in Belgium that are not high enough for certain trucks to pass through. So we want to avoid collisions there. We often have trucks that don't notice the plates on the road, so they don't know that they cannot fit under the bridge. They cannot estimate it themselves well, so they keep on driving, and while they're driving, they didn't notice it and they collide with the bridge. Of course, as a customer, you don't want that. If you own the bridge, you don't constantly want to start repairing that. So we provided the hardware there, which is an AMPR camera to read the details of the truck, and then a height detection sensor to read the height of the truck itself. We send that off to our platform, and then we take an action if the truck is too high. We send it off to the system to okay, now display on an LED screen the number plate of that truck, as well as a warning you're too high. Make sure you take a deviation of the road. Another example that we do is crowd counting. So they're by far the most use cases that we have because more and more cities are becoming interested in those. So cities want to have insights in okay, what are their customers visiting. We have that on one hand with the location analytics I talked about, where we have at the macro level, okay, this is the amount of mobile phones that we track in an area, and based on the cells, we can say, okay, this is how that changes over time. But as well on a micro level, we want to install sensors to give a more detailed level of, for example, just a street, because a cell we cannot say to the cell tower on one cell, monitor that street. So for that, we install microsensors, and these can really narrow it down to a street or to a smaller area where customers want to get inside of. For example, in cities, customers typically want to see, okay, what is the shopping street having in terms of attendees? What is a certain event that we hold 2 days in a year? How many people are visiting that event? Now we hang up the sensors, we connect that to the IoT platform so that we can provide a real-time insight to that customers. Why is that valuable? Yeah, just think as a city, you want you have a shopping street, but you need to rent out a building in that shopping street. So you can provide to future customers, okay, these are the amount of customers you can expect to have, so that they can get an insight in the potential revenue that they can start generating and the market reach that they will have. As I said, in our platform, we digitalize everything as a digital twin. So on the left, you can see that digital twin behind the scenes. This is not what we will offer to the customer because it's a bit too complicated for them. But internally, we really model everything as a digital twin so that we can see the connections and how everything is related to each other. While to our customers, we can then provide, for example, a 3D overview. So on the right, you can see in this case a 3D visualization of our customers with the entry points of the shopping street area and how busy it is at a certain moment in time. And we can change it then based on the last 5 minutes, the last hour, the last day, and change the colors based on, okay, how crowded is this there now, to avoid overcrowdedness, for example. And then finally, another use case to mention is the car detection. So yeah, as I explained earlier, we really want to detect these cars. We want to classify them. It's not an easy task because it's just not simply recording the audio. It's as well classifying that audio and making sure that it's tuned for the customer their needs. Because one car has a specific sound, but you don't want, for example, an electric car which might have a similar sound and the cars to be detected and the police to be warned about it. So we work together with authorities to pinpoint the type of audio that they want to be detected, so that they can start to act upon that. As soon as they have a warning, they then go check manually with the camera or instantly send out police people to start to intervene and to give them a fine so that they know they can drive there. And that results in a dashboard that gets created where we classify each car coming in, where blue in this case is the honking vehicles, purple is the trucks and buses, green is just normal silence, and that we can start showing to the customer, okay, this is the sound at current moment in time, it constantly gets updated, and then if a certain threshold is reached of accuracy, we send out an alert, okay, now is the time to intervene. Now, most important, and why of course everybody's here, how does this work behind the scenes and how are we utilizing Dapr? So if we look at the bigger picture in the eye-level architecture, okay, we have these sensors coming in and we have the IoT platform, but the big building blocks that the IoT platform consists of is, okay, we have sensors, they need to be real-time, processed in real time, and that processing then needs to be stored. So all the events, single events that come in need to be stored, send off to a backend so that the front end of the back office can query that. And then if the backend receives an event, it needs to be able to trigger a certain custom logic, customer specific. So for example, with the slow vehicles, we need to be able to send off to the LED screen, okay, there is a slow vehicle ahead, now change something. That's always custom. To the truck height detection, we as well need to send that off to an LED screen and say, okay, there's now a custom vehicle, and that's the custom logic part. And for almost all the components that we have, we're utilizing Dapr. Beside Event Store, because that's just a plain database, and then our front end, which of course is just some plain static code, because we try to statically optimize that so that we don't have too much complex logic in there. But in our sensors, we have custom protocol converters, which convert one protocol to the other. There we utilize Dapr. For real-time processing, we utilize Dapr, and as well for our back office and our custom logic, we try to utilize Dapr as much as possible. If we quickly go through that, so just to give a recap, Dapr has a certain amount of building blocks. So at one hand, it can do invocation, where it triggers a microservice, and you can have microservice communication between each other. We can have state management, publish and subscribe, so that if we have an event broker, we can subscribe to the events coming in from the event broker, but we can as well put events on that event broker. Bindings, which is for custom components, such as, for example, you want the Twitter API to be consumed, you want the normal HTTP binding to be consumed. That can be done through bindings, actors, which is just to provide some custom logic on the actors, secrets, and configuration. And then one that is a bit less visible thanks to the camera. But to give insight, so on the sensor part, so for sensor integration, what we typically utilize Dapr for is mostly the bindings as well. But we utilize that for protocol integration. So we need to convert one protocol to the other, and we don't always want to implement the protocol layer because it's sometimes a hassle to implement. But we can utilize Dapr, for example, to do straight MQTT connections for us. Then if we have the payload coming in, the sensors do send a quite large or sizable payload. We don't want to send that payload off to our event broker. An event broker, its task is to broker the events, and you want to keep them small. So we're talking 64 kilobytes, smaller typically if we prefer it. Maximum is 256 kilobytes. But if you look at our ANPR cameras and normal cameras, we typically see all the images coming in as well. And those images, we want to take them out of the original event, upload them to a separate store, get back the file URL, and then send that with the payload then stripped from the image with the URL in place, which then condenses it to the required size. We utilize Dapr for the image upload, for example. And then as well for forwarding the events, so we take the events and we send them off to, in this case, an IoT hub, Azure IoT hub, and then we as well utilize Dapr for that connection. For the real-time processing, almost exactly the same. There we typically utilize then the PubSub for listening to the events coming in. And then as soon as we receive an event, we start working with that and we send that off to a storage system where we utilize then the Dapr binding. Then for metadata, yeah, okay, the metadata is sitting somewhere, but the back office needs to be able to reach it. And then the back office will utilize Dapr to figure out where the metadata is sitting, download the metadata, and then provide that back to the customer on the front end. And then for our customer specific, yeah, that is the custom logic is really customer specific. We like sending that off to an LED screen. We try to utilize Dapr there. Sometimes we can't, but we try to utilize Dapr as much as possible. Because why are we using Dapr? So what are really its advantages for us is it reduces our time to market. We don't like we have the advantage that Dapr writes a lot of code for us, which means that we can reduce the time to market because we don't have to write it ourselves. It's already integrated, it's already tested to be stable, and they're so easy to utilize that we can instantly start using new components. So for example, if you want to get started with MQTT, we could do that within a matter of hours rather than days, just because they created the components, they created the building blocks, and those work for us. Then the second point is really the portability. So as Proximus, we are quite sensitive to working in clouds. So we want to make sure that we have covered all our risks. We want to ensure that if, for example, Dapr stops being in existence, which we hope not, we can move away from it. If one cloud stops adoption of its components, we can move away from it. If one cloud suddenly increases the cost of the component and we want to migrate towards another cloud, we should be able to do that. And Dapr offers that. Dapr is open source, so in the risk that it's going to stop offering its services, we can just clone it and continue working with the services that are already in there and potentially take everything in-house for development. If we want to move from one cloud to the other, Dapr offers just the small tweaking of a configuration file, which allows you to then move from one event broker to the other. So to give you an example, for some of the projects, we were utilizing Cloud A, then we moved them to Cloud B, just changed the configuration files, then we moved it towards Cloud C because we were testing some of the cloud components. We again modified the cloud configuration files, and we could do all of that in the time span of one day, which is mind blowing. Normally, you would have to get accustomed to all the different SDKs of what the cloud offers, the way of interaction, and Dapr all integrates all of that for you out of the box. And then third for us, one of the by far the biggest advantage is the support of its ecosystem. Dapr keeps on developing new components which are tested, found stable. They have their different life cycle on making sure that the components are found to be stable, which allows us to move forward and to really focus on what we need to focus on, and that's creating our business value. Dapr supports us with the technical capabilities. We have to just integrate them and create a business value for our customer, which is why we as well love Dapr. And as Proximus being, we try to contribute as much as we can to Dapr. So for example, me myself, I'm the JavaScript lead SDK maintainer. So I try to as well contribute everything we learn at the Proximus side, or all the challenges that we see or issues that we see in the SDK. I try to contribute that back to the community, do weekly meetings as well with the teams there to ensure that we can provide everything we do back. And this is really how Proximus utilizes Dapr and what we're working on. So I would say I open it up for questions now. So if there are any questions, feel free to shoot. I can answer them now, or you can definitely send an email if you like the presentation or have future use cases that you want to cover. Thank you.